All right, so I want you to have quick access to getting one period of a trig function like sine, so that you know this crosses at pi and 2 pi, and the amplitude is 2 pi. The amplitude goes up to 1 and down to -1. So that's one sine wave, right? So let's do one cosine wave. So just between 0 and 2 pi, this is what it looks like, right? So at pi here is where it reaches its minimum. So know the x-intercept. So this is pi over 2, and this is 3 pi over 2, where it crosses, goes up to 1 and down to -1. Those are just crucial points that are just going to come up. So tangent of x, asymptotes are a very big deal. So you should know these are the asymptotes at -pi over 2 and pi over 2. And it looks like this. All right, so if I'm going to draw y equal cotangent of x, cotangent is not just the reverse of this. It's got asymptotes at 0 and pi, and it comes down like this, and it crosses here at pi over 2. All right, so secant of x is 1 over cosine. So it's got the cups that come off of this graph, right? So where this is equal to 0 is where there are asymptotes. So here at pi over 2, there will be an asymptote. And then at -pi over 2, there would be an asymptote. And it makes cups up here. And over here, there'd be another asymptote, another cup here. So -1 and 1. So that's secant. And then cosecant. Let me do that one in blue again. So cosecant is the cups off of the sine graph. So that would look like where there's zeros, that's where they're asymptotes, right? So here would be 0 and pi and 2 pi. So a cup here and a cup here where this is 1 and this is -1. All right, those are important to be able to get a quick sketch of. Again, you've got your calculator as a help. These are identities you're going to need to algebraically know. So there's many trig identities. These are the 3 you really need to know. Sine squared and cosine squared is 1. So tangent plus 1 is secant squared. You just have to have memorized. Sine of -x is negative sine. Cosine of -x is just cosine. And this is just playing with SOHCAHTOA. And then knowing the relationship of secant, cotangent, and cosecant in relation to sines and cosines. So be very familiar with those. All right, so basic things just to get your brain warmed up after a summer. Circumference of a circle, area of a circle, just you need to know volume of a box, length times width times height, perimeter, just reminding you. So all of these are very wrong. You know, this is very bad math, this is very bad math, and this is very bad math. So I want to make sure you're never going to do bad math. Many times it happens that you're moving along in a problem and you're kind of stuck, so you just think the bad math is going to work. Just be careful. All right, so let's work on domain and range. So domain are the x values that you're allowed to put into a function. So what you're going to be watching for, never divide by 0, have negatives under the square root, and make sure when you're taking the logarithm, it's never of a negative number or 0. So the range are the y values. All right, so thinking about the graph of y equal ln of x, I'm having you graph it so you can look to see what you think the domain and the range is. So the domain of this inside the argument it's called of the ln, that has to be bigger than 0. So there is a vertical asymptote. The range are the y values, and that's all real. So a double bar there with the on the R means all real values. So it goes up and down everywhere. This is that graph. So I want you to get comfortable with it. It's going to keep coming up. So the domain is all reals except x equals 0. It's the quickest way to say it. I don't have a criteria of how you need to give your answers. Then the range is going to be the y's are going to equal plus or minus 1. All right, so let's think about what this is. This is really similar to this. Here I can see that x cannot equal 2, so 2 is the number where it's going to change. And if I was to plug in x values and find out what the y's are, if I plugged in 3 or 4, I get a y value of 1. If I plug in 0 or 1, I get a y value of -1. So here it is. So this is that graph just shifted over where 2 is the value you cannot use. All right, so what's the domain? The domain will be all reals except 2. And the range, again, will just be plus or minus 1. Oh, I'm playing with this one again. So try plugging in a few points. I think this is the best way to do this. So if I plug in, say, I just keep close to the number 3. So if I put in 4 and 5, put in the numbers here, so I'll put 3 here. If I put in the numbers 4 or 5 to the right of 3, I end up getting -1. So -1 down here. And if I plug in 1 or 2, I end up getting +1. So it's the other way, which is different. All right, so the domain is going to be all reals except 3, and the range again will just be your plus and minus 1. All right, and this last one here. So radical, you have to have a positive inside the square root. So negative x has to be bigger than or equal to 0, right? Because you know you can take the square root of 0. And if I multiply by negative, it changes the sign. So that means its x's are smaller than 0, smaller than or equal to 0, and it makes the graph look like this. So that's the domain, and so the range will be all the y values that are bigger than or equal to 0.